All right, good morning, everybody. Today is Codeforces round 662. It's a Div2. As usual, at the end of contest, I'll explain all the solutions to the problems that I know how to solve, and I'll be kind of sharing my thought process during the contest. The next 15 seconds, though, I have to quick type up my template because it got deleted somehow. So we'll just do one without fast scanner. Well, I guess we're done. So let's go. We'll see. All right, problem A. Oh man, what? Rainbow Dash, Fluttershy, and chest coloring. One evening, Rainbow Dash and Fluttershy, are these people? Have come up with a game. They're ponies, okay. What? The ponies are friends. They've decided not to compete in the game, but pursue a common goal. The game starts with a square flat grid, which initially has the outline borders built up. These two ponies have flat square bricks, which startups has 1 by 1. Rainbow has an infinite amount of light blue, and Fluttershy has yellow. The blocks are placed according to the following rule. Each newly placed block must touch the build from the previous turn's figure by its side. Initially, you start with just the borders. At each turn, a pony can place any number of blocks of her color according to the following rules. They're in the form of chest coloring. She wants to know the minimum number of turns they need to get the chest coloring, covering the whole grid with blocks. So it's n by n initially, right? So it's like, it's 3 by 3. It's what? So it takes 2 moves. Well, it's gonna wind up being a really simple formula. So maybe we'll just do it for small things. 4 by 4 takes 3 moves, they say. Come on, all right, so you can do the corners like this. I guess 5 by 5 is interesting enough. So the first turn you get these. Then the second turn they'll fill in all of these. So the first two turns you get the first row completed and then half of the second row. Is it always n minus 1? Okay, so then we get these. All right, so then the next turn, you get these. N minus 1 is very convincing. Let's do 6 just to be safe, because I don't want a wrong answer. So that's the first. The second would be this. Well, you just have the outside border, and then also half of this inside border. I'm doing this inside border wrong. Well, oh, I guess we can, yeah, we can do this like recursively. So n layers, if n equals 1, this takes 1. If n equals 2, that's a 2 by 2, that takes 2. Otherwise, in like f of n will be equal to, takes 2 moves, time, or plus f of n minus 2 minus 1, because we get one of those moves for free. So yeah, so this is just going to be 1, 2. This third one will be 2 plus 1. So this will just be 2, right? Then 3 will be 4 minus 1, which is 3. 4 will be 2. Wait a second. 4 will be what? So 3 will be 3 minus 1, which is 2. 4 will be 2 plus 2 minus 1, which is 3. 5 will be 2 plus 2 minus 1. So maybe it's not n plus 1. Or n minus 1. So 5 will be 2, well, something plus, yeah, 2 plus 2 minus 1, so 3. And then every 2 it increases. So this is 1, 2, 3, 4, 5, 6. So this is just n plus 2 over 2. Cool. Let's try that. Next int over 2 plus 1.
Well done, sir. I see you on problem A.
Took a bit, but that's fine. Oh man, took a very long time. Well, Applejack and storages. This year in Equestria was a year of plenty, so Applejack has decided to build some new apple storages. According to the advice... Hello? Okay, thank you. According to the advice of farm designers, she will choose to build 2 storages with non-zero area, one in the shape of a square, the other in the shape of a rectangle. She will build the storage using planks. She's going to spend exactly 1 plank on each side. Okay, she can get the planks from her friend's company. Initially, the company has n planks, and Applejack knows their length. The company keeps working, so it receives orders about the plank itself. Applejack's friend can provide her with the information about each operation. For convenience, he will give her information according to the formula. Receive this many planks of x, subtract this many planks from x. Sure about whether she's going to order planks, she wants to know if she can build, or if she can order the planks to build rectangular and square storages out of them. So after each event. Yes, okay. So initially you have 5 1s, 1 2, so you can't do it. But then when you add a 2, you can do it. You can have 4 1s. Why could you do it? Why is this possible? One, 2, 1, 2. Am I missing something? The square would take 4. Oh, can they be next to each other? Can you have, like, is the answer they're looking for, you could do like this? Is that the goal? So this seems like slightly more difficult than a Div2b should be. But I think, let's walk out through all the cases. if you have a 4 and a 2, well, if you have a 5 and a 2, that's possible. If you have 2 4s, that's possible. If you have, how many things of the same length do you need? If you have 7, right? You need, it's like a 7 segment display. You have 7, that's possible. Otherwise you could have a 4, a 2, and a 2, that's also possible. I think those are the only ways of making it. Yeah. 1, 2, 3, 4, 5, yeah. Yeah, so these are all of the things we have to look out for. So, yeah, we can do this with just a binary index tree if we want prefix sum. That should be fine. There's probably a better way of doing it, because requiring prefix sums for a Div2b is at best a sketchy problem setting choice. But that's fine. I think it would be a bit more caseworky without this, so I'm gonna just do it, and we'll live. We need fast scanner for this though, so let's type that really quick. Alright, then give me try catch. And then let's go. Okay. So we have our temporary class. Now we have, oops. Come on. This is unhelpful. Get our fast scanner, and yeah, okay, good. So now we read how many of each thing we have. Oh, it's a single test case even. Okay. Int array A equals read this array. Just make it 10 to the 6th, because why not? And then we can add each thing to this bit. So increment this thing by 1. Once we have all of those incremented, we need to check each case. Oh, wait, maybe I'm misreading this. Got it. So after the first one you can't, after this one you can. Okay, so I'm misunderstanding the problem. That's fine. So this 5 and 2 is not actually possible. This is 6 and 2 rather, not 5 and 2. So this is 6 and 2, so that works. And the 7 is impossible, it's really an 8. But otherwise, that's right. Okay. Then we read the number of queries, right? Yeah. the type first. Well, and then int val equals fs dot next int. Okay, now bit dot update the value by the type equals negative. That's the case, -1, otherwise by 1. Okay. So now check if it's possible. So boolean possible equals a couple things, either bit.query .read n is greater than bit.read 8. Oh, yeah, this doesn't work. So this needs to be a cumulative sum array, or a frequency array, rather. So for each index in the frequency array, we need to update it. For each index in I, or in A, we need to update that frequency. Update the frequency of that element. Yeah, okay. Frequency of val by -1. If type, well, val plus equals type equals the negative, that's the case -1, otherwise 1. And now frequency of val. Oh, wait. That's exactly what I was doing. This was just right before. Okay, we have one of each of the things that we start with in A. Yeah, I was right before. Okay, one of each of the things we start with, then we see this, we either add 1 or subtract 1. So if bit.read bit.n is greater than the number of things we have 7 or fewer of, okay, possible or equals, what else can we have? We have 6 and 2, bit.read n minus bit.read 5 is greater than 0, and bit.read n minus bit.read 1 is greater than 1. Okay, that's also possible. What else? So then there's also 4 and 4. So if bit.read bit.n, you gotta be careful not to mess that up. Bit.read bit.n minus bit.read 3 is greater than 1. That's also true. We also have 8, and then 4, 2, and 2. Okay, so hang on, this was 6 and 2, so this is 4, so this needs to be 3. And then the number of 2's plus the number, that has to be at least 3. Yeah, okay. It's out. Alright, this should just be out. If it's possible, print yes. You don't need to build a square and rectangle. Okay, you can't use common planks. You don't need to use all the planks. You can't glue or cut existing planks together. That is, to build a square, you need to use 4 planks of the same length to build. Yeah, okay. Yeah. It's understandable questions people ask, though. I was worried about the same thing. So if it's possible, print yes. Otherwise, print no. This is a print writer. Man, this Div2. I don't know what to think at the moment. Maybe I'm just doing very poorly. Okay, so let's try this. Int after int I return read n minus read n minus 1. Okay, so this is bit dot after 8 is greater than 0. This is after 6. After 6 is greater than 0, and bit dot after 2 is greater than 1. Bit dot after 4 is greater than 1. Bit dot after 4 is greater than 0, and bit dot after 2 is greater than 1. Okay, so update this by -1. Val plus equals this thing now. And now bit dot update val by 1, or by wait, no, that's right. We either get or lose one of these things. That's the problem. This is, we start with all of these things. So, well, I guess let's try each thing. For int I equals 0, I is less than 10, I plus plus. So I plus bit dot after I. They are all 0. Why would that be? Update I by n. Is this read array broken? That's fine. So we should have lots of 1s, right? Oh, they're not all 0. We have 6 1s. No, man, I was doing it wrong. That's fine. Yeah, I don't care about the frequency of things. I care about how many things have a frequency greater than this value. Yeah, that's fine. So int array frequency equals new int array 10 to the 6. Or how big can the values get? Yeah, 10 to the 5th, but that's fine. 10 to the 6th is fine. So now for int I and a, frequency at I plus plus. For each I in the frequency, bit dot update that thing by 1. Now we have a bunch of queries. Yeah, okay, we will pause with that for a minute. Int old frequency equals the frequency of val. Int new frequency equals the frequency of val plus this thing. Oh wait, frequency of val plus, yeah, plus either we add or subtract 1 from the frequency. Old frequency by -1. New frequency, yeah, okay. Then update the new frequency by +1. And then, what else do we need? We need to update the frequency. Frequency at val equals new frequency. Still wrong, that's fine. But we should have, there's 1 after 5. Yeah, okay, that's fine. So Oh, that's weird. Something's getting destroyed. So 0 has a lot initially. Then we first we add a 2. So now the frequency of 2 should be 2, but it's not. Man, dude, this Div2B, holy cow. Old frequency is 1, new frequency is also 1. I'm an idiot. That's also very wrong. Okay. So I'm saying we can get a 4. This should be greater than 2. Good. Okay, that took way, way too long to debug. Holy cow. My goodness. All right. Well, you live and learn, right? Don't be stupid is the lesson of the day.
Well done, sir. AC on problem B.
Okay. That was a nightmare. That was disastrous. Problem C. Pinkie Pie has brought a bag of patty cakes with different fillings, but it appeared that not all cakes differ from one another in filling. In other words, the bag contains some patty cakes with the same filling. Understand. Pinkie Pie eats the patty cakes one by one. She likes having fun, so she decided to not simply eat the patty cakes, but also try to eat the patty cakes with the same filling way too often. Okay, I don't really understand, but that's fine. To achieve this, she wants the minimum distance between the eaten with the same filling to be as large as possible. The minimum distance between, so she eats a bunch of patty cakes, she wants the minimum distance between any two eaten to be as big as possible. Wait, what? Oh, she doesn't want to eat them with the same filling too often. Got it. She can eat the patty cakes in any order. She is impatient about eating all of the patty cakes up, so she asks you to help count the greatest minimum distance between the eaten patty cakes of the same filling amongst all things. I see. Yeah, okay. So, just the most common one matters, right? If it occurs over half the time, the answer is 0. Otherwise, oh, maybe it's not true. Well, we could binary search. So we can do n log squared, at least. Yeah, we can binary search the answer. If you can do it for some amount, you can definitely do it for a larger amount. And then what does that look like after? So we've got, take the biggest one you can, put that here, and now say it's unavailable until some given position. Yeah, we can do that. Okay. Is there anything else this week? This was in temp. Oops. What was in B? So B is really our template. And then this temp is really problem B. All right, so, oops, fast scanner. Okay, is this multi-test case or no? It is. That's fine. So int n equals this. And then we've got some array. And then all that matters is the frequency of each thing, yet again. Yeah, well, we'll just make it size n for int I in the array, frequency at that minus 1 plus plus, because they give it to us 1 based. So now we need a priority queue. Priority queue integer pq, priority. Well, we need a binary search really. So for int min equals 0. What am I doing? Int min equals 0. The max will be equal to n. Well, if they're, do they guarantee they're not all different? Each bag contains at least 2 patty cakes with the same filling. Okay, so this will be n, I guess. That's fine. So while min is not equal to max, and do some stuff, then sys out the minimum. Yeah, okay. This is really like min plus 1, sort of. It's the number between. Yeah, most people would say the distance between these are 4. By any reasonable definition of the word distance. 1 and 5 should definitely be 4 apart. But if you'd like, I can do that to make you happy. All right, anyway. Static Boolean possible for some int array f and some int like distance. So we need to do that later, but if it's possible to do this frequency array and the distance mid, then we do one thing, otherwise we do another. All right, so if it's possible, can we make it longer? Yeah, if it's possible, we might be able to make it longer. So then min equals mid. This needs to be plus 1. If it's not possible, then max equals the mid. So we need to make it shorter than what it is now. Got it. All right, how do we check if it's possible? So we need an array list of integer array lists. Use new array list. Size n. Okay. So for int I equals 0, I is less than n, I plus plus. Now we want to read in the things, so we need a priority queue integer q equals new priority queue. Java has these, like we remove the smallest thing from it, so I need to store them negative. So for int I in lists, or int to add in lists set I, pq.add minus to add. So now we have all these things in our priority queue. Int to place equals, well, okay, so if to add dot pq rather is empty, then return false because we have nothing we can place here. Otherwise, int to add equals pq.remove. Then we want to place this here. So to add plus plus. And now if it's 0, we're done. If it's not 0, then we might have complications. If I plus the distance is greater than or equal to n, then return false because we won't be able to place it. But otherwise, list set I plus dist dot add to add. Return true if we can do all that. No, not the case at all, really. We got this right at least. This looks sketchy. Min plus max. We're saying we can't do 1. Oh, I see. Yeah, this has to be at least 1, otherwise it doesn't, we don't add it to the right places. Okay, so not right at all. We always take the biggest thing that we can remove, right? Yeah. So let's just print that. So this is out at this position using plus -2 add. So we have 3 2s, right? That's it. 1 2, 2 2s, 3 2s. Yeah. Wait, we shouldn't have 3 2s because that wouldn't add up to 7. We have a 1 and 3 2s. 1 test case. Okay, position 2, I'm using a 2. 1, I'm using a 2. 2, I'm using a 2. Oh, so when the distance is 4, we say the distance with 2 is impossible. Why are we using a 0? We should never be using a 0. That should always be a problem. Yeah. So don't add 0s, I guess, is the goal. But also, I don't know, that's interesting. Like, that shouldn't be a problem. If I is not equal to 0. Am I being silly here? For each integer in this list, I'll add it. So 3 2 0 4. Man, dude, I am just struggling today. Maybe it's just a wacky hard set, but I don't know. Div2b it got to me. Well, could we get TLE? We could get wrong answer, it's possible.
Well done, sir. A C on problem C.
All right. Well, let's take a deep breath. Okay, so looks like the set is just unreasonably hard. Yeah, it doesn't look like I'm actually doing that bad. Looks like the set's just insane. Like for a Div2 set, man, if you're an LGM, you should be solving set. Because this should be, well, I guess maybe not yet, but still, it's hard set. Rarity and new dress. Carousel Boutique is busy again. Rarity has decided to visit the pony ball. She surely needs a new dress, because going out in the same dress several times is a sign of bad manners, if you say so. First of all, She needs a dress pattern, which she's going to cut from a regular piece of multicolored fabric. Piece of multicolored fabric has N by M square straps. Best pattern must include. Okay, so you've got like a bunch of these things. I see. Must be square. Wait, what? Must be this. A dress pattern must be the square, since she's found it from is the sides. Yeah, okay, I think I understand. How many ways are there to cut a dress pattern that satisfy all the conditions that do exist? What are the conditions? Oh, they have to be all one color, I guess, maybe? Is that the problem? Dress pattern must be square. The sides of the pattern must form a 45-degree angle. I see. So all of these, do they have to say like it's all the same? Yeah, okay. Only includes scraps of the same color. Got it. So there are 10 ways here. There's the every position and also the 3x3. So now the question is just, oh, maybe we could binary search. Can we binary search? It's sketchy. Well, yeah, okay. So this is a good thing to test. I'm gonna turn my fan on because it's just like ridiculously hot in here. Alright, hope the audio is not absolutely terrible. Yeah, okay. So the classic way of doing this is to rotate everything. Let's just draw out what that looks like. Man, that's not the right way of drawing a grid. Alright, so we initially have, let's say we want to look at this pattern here. So we change it to like x plus y and then x minus y. It's the common transition. So x plus y will be, which of these diagonals are you on? So we'll draw these, I guess, in blue. So how far this way do you go? Where this is like 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is the x-axis. What's the new y-axis? X minus y. So if you increase your x, that's good. So yeah, so it's like this. It's your new y-axis. So this is 0. This would be 1. This is 2, 3, 4, 5, like this. Or wait. Yes, this is like this. This is like this. So the side effect of doing this is that you now only have things that intersect like here. That's an intersection, but this intersection isn't actually a space. So you only have a checkerboard pattern now. So equivalently, this is the x-axis, this is the y-axis. Your spaces are this, this, like this sort of thing. And the rhombuses need to be an odd height, right? This needs to be odd. You can't have an even height rhombus because that isn't really a rhombus. Yeah, a 2x2 rhombus doesn't exist. So we just like, how many are we expected to have? Well, we're expected to have 1, then 5, then 1, 2, 3, 4. Oh, hang on a second. 1, 2. This is kind of hard to count. So this is, there's a 3x3 and then a 2x2. So 3 squared plus 2 squared. Before that we had 1 squared plus 0 squared, and then we had 2 squared plus 1 squared. This gives us the 1. Yeah, okay. So here's how you count how many should be in the square. Then we need to try all possible starting values. So how far left can they be? Well, we have to add n to this, right? So plus n to all the positions in order to shift this down. Once we have it shifted down, then we can do the same thing. Yeah, okay. So the idea is we read in all of the, oh wait. Do we need to do this for each letter? Can we even afford that? Yeah, so we need to remove the binary search. So in order to do this, we would have to initially look at this previous thing minus 1. Yeah, previous thing minus 1, and then start counting up from there. Well, it's either the... Could be the previous thing minus 1. Or it could be this thing minus 1, or it could be this thing minus 2. It could be this minus 2 or this minus 2. Not just the previous minus 1. Because we don't want to be n squared here, or I guess total number of spaces squared, because we're already very tight on the time limit. Like, how tight are we even? Wait a minute, what? We're already, like, incredibly tight. Why are bounds so big? This is like crazy tight time limits, man. What are they doing to us? And the other problems are impossible. Ah! I don't like this set at all. Do they not want n times m times 26? Can we have that much memory even? 256 megabytes. Well, do we just, like, ignore the fact that time limits will be tight and do it anyway? Or do we find a better way of doing this? I don't really see how you can... Well, okay, is my fan killing the audio? Yeah, it's not great. Turn it down. Alright, so... Can we even do n squared times 26? I think we don't have a choice. We can do each letter separately, maybe. That might speed it up a bit. There are also no mods, so we're kind of fast in that front. It's gonna be optimization time. I guess this is the rest of contest, huh? Yeah, unfortunate. Well, I might be converting to C++. For this problem, at least. But we'll try. We'll try. How about that? Also, can I just say, like, if the goal of a problem set shouldn't be to make sure no one solves it, maybe everyone's going for E2. But, like, if this is what your problem set looks like, I would argue it's too hard. Maybe, should we read it? Let's read it. It's an easier version with smaller constraints. Received a new task. This time she was asked to decipher the ancient scroll containing important knowledge of pony origin. To hide the crucial information from these evil eyes, pony elders must cast a spell on the scroll. Spell adds exactly one letter in any place to each word cast on it. To make the path of knowledge more tangled, elders choose some words in the scroll and cast spells on them. She knows the elders admire the order of all things, so contains words in lexicographically, so the words are sorted. She's asked to delete one letter from some of the words to get some version of from some words to undo the spell to get some version of the original scroll. This problem is very difficult to read. Okay, well, we don't care about lexicographically smaller. So you have a bunch of words that are sorted. You have to delete one letter from some words, and you want to get the original scroll. So how many ways are there to delete one letter from some words that keep the thing sorted? Is that the question? Man, they're just like squeezing every penny possible out of the bounds. Why? It doesn't seem necessary to me. Whatever. What is the question? Yeah, could have written an empty word. Yeah. So basically, all this problem is how many ways are there to delete one character from some groups of words so that it stays sorted? Is that it? Because if that's it. Now, why are these not sorted? Oh, because you have to delete either this or this, maybe? Maybe that's why. Yeah, okay. And then this, I take it, just has very big bounds? Like 10 to the 5th or something total? 10 to the 6th total, because why not? You know, if you can make bounds insane with a tight time limit, you might as well do it. Who codes in Java anyway? Okay, and no one has any solves on either of these at the moment. Okay, I think it's more excusable that these have no solves this far into contest, because it's possible all the LGMs are like, well, it's a Div2 contest, I'm solving Div2, I'm solving like E2, and all of the medium people are like, well, I'll just try E1, but haven't gotten there. Nevertheless, we haven't solved D even yet, so that is what needs to happen. So we'll do that first. Let's actually look in my room and see, are people TLEing here? What are these? Are these wrong answers or TLE? He's wrong. He's wrong. He's TLE. Ooh, can we see what language? C++. So maybe he's trying a binary search. You're C++, you're also C++. So it looks like, yeah. So it looks like wrong, or like TLE isn't as scary as possible if you're smart about it. Okay, so let's do D, and then we probably won't have time for E2, so E1 it is. Okay, so read N and M. N equals this. M equals this thing as well. Yeah, okay, so I want to make it just whichever's bigger. because they might just be the same, so our code would need to handle that anyway. And then we'll just ignore zeros. Yeah. So for int I equals 0, I is less than height, I plus plus. Yes, we can make this y, that's fine. It's a typo originally, but we can make do. So read the line. Now for int x equals 0, x less than width, x plus plus. Board at x, y will be equal to line at x. Oh, we need that. Okay. So now we need to make some changes. Need to make a cumulative sum array. So let's make I guess a fixed character array. This will be 2 times n by 2 times n. Is that fine? The minimum it can be would be n0, well, it'd be negative n to positive n on one side. That's n plus 1 though, right? It's n plus 1 things. The other thing could be 0 to 2n. So these both have plus 1s. Yeah, okay. So now for int x equals 0, x less than n, x plus plus. For int y equals 0, y less than n, y plus plus. Fixed at x plus y. That's the new x coordinate. The new y coordinate will be x minus y plus n equals board at x, y. Yeah, so that should be fine. Okay. So now we need to go through each character that we're considering. Yeah, equals a. C is less than, it's really a character, right? C is less than equal to z, c plus plus. And now we need to consider all of the things in the entire board. Or we need to build the cumulative sum array first. Okay, so it's going to be fixed plus 1 by fixed plus 1. Or I guess it'll be fixed. Yeah, we need to make this new n. So n equals fixed length. So now it'll be n plus 1 by n plus 1. So now we need to build it. For int x equals 0, or x equals 1, x less than or equal to n, x plus plus. For int y 0, y is less than or equal to n, y plus plus. CS starts at 1, so x, y. Will be CS at x minus 1 y plus CS at x, y minus 1 minus CS at x minus 1, y minus 1. Okay, so that's the prefix sum. Oh, plus possibly this thing. So plus if fixed at x, y is equal to this character, then add 1, otherwise add 0. Hopefully that's fast enough. Okay, now we need to create our answers. Or really, I think it can just be n by n. Or I guess, yeah, I guess this is fine. Is this fine? Yeah, we'll make this fun. Okay, so now static boolean works. So we'll have some int x1, int x2. or int y1, and then int amount, and then this CS array. So int, okay, this is size really. So int expected will be equal to size times size plus size minus 1. Oh wait, size is always odd, right? So int smaller will be size over 2. So if it's 5, that should be 3. So it's really size plus 1 over 2. Well, no, size over 2 is the smaller. Yeah, okay. And then the bigger will be smaller plus 1. Good. Then we need to calculate how many expected. That's bigger times bigger plus smaller times smaller. Then we need the real. It'll be CS at x1. Well, okay, int x2 will be x1 plus size minus 1. Int y2 will be x or y1 plus size minus 1. Alright, so int real will be CS at y2 plus 1, x2 plus 1, y2 plus 1, minus CS at x2 plus 1, x1, minus CS y1 at x1, y2 plus 1, plus CS at x1, y1. Turn real is equal to expected. All right. So now, x equals 0, x less than n, x plus plus, y equals 0, y less than n, y plus plus. So now answers at x, y equals the current ans, whatever that winds up being. Math.max of 3 things. Answers at x minus 1, y, well, just x, y. And then math.max of 2 other things. Answers at x, so this thing minus 1, or x minus 1, y plus 1, minus 2, or answers at, oh, we can't always do this either. Yeah, okay. Int ants equals 0. Let's make this n by n then. If x is greater than 0 and y is greater than 0, ants equals math.max of the answer, and answers at x minus 1, y minus 1. So go back by both. Otherwise, if x is greater than 1, then x minus 2y, this thing minus 1 rather, this minus 2, and then similar thing for y. Minus 2 as well. Okay, so now while this needs to start off being odd. So start at -1. Yeah, okay. So long final answer, I guess total is 0. And sys out total. While it works at x, y, the current ants plus 2, and then the CS, then ants plus equals 2. And then if this ends up working, this is greater than 0, then total plus equals the answer divided by 2, well, ans plus 1 over 2. We can do that anyway, because it'll always be negative 1. I think this is fine. Famous last words. Okay. Could we overflow here? These are both at most like 10 to the 4. So I think we don't need to concern ourselves with that. What's going on here? A single test case, I guess. I do like Vuv's method, or Vovu's method of, I'm just really liking him as a problem setter, to be honest. I really like his, like, just multi-test case everything, so at least it's consistent. Because, like, I understand you have to multi-test case the small stuff, because, like, otherwise servers go down. X minus 1, y minus 1. But, like, for the big stuff, it's kind of annoying to have to change it. Okay, 8 is very unexpected. Interesting. Let's try like a 1 by 1 maybe. 1 by 1. Print just an A. Is that not right? Oh, interesting. Yeah, okay, so what do we need to check here? If x1 plus, yeah, if, what is it? x1 plus size is bigger than the length, greater than or equal to cs.length, or y1 plus size greater than or equal to cs.length, then return false. Okay, interesting enough, I guess. But a 2 by 2, that's wrong. Surprisingly wrong. I would have expected something else. Would have expected like 3. All right. Yeah, well, we'll get this problem, I hope, at least. It'd be kind of weird if we didn't. So it's static void print some char a for int x equals 0, x less than x, y equals 0, a at 0 dot length, y plus plus. Sys out new line, sys out a x y is greater than a. If it is, print out a at x y. Otherwise, print out a dash. Okay, so let's try something that's easier to see. If we have A, B, C, D. Okay, so Really this is inverted, but A should be at 0, 0, and it's not. What should this look like? So we have A, oh wait, it's not, it's like, it's backwards. Yeah, okay. Should I just do it like this then? I can just print it backwards. It's greater than or equal to 0, minus, minus. Or I'm doing this one, 2, 2, A, B, C, D. Length minus 1. Okay, so this should be A, B, C, D. This is what it looks like. Then when we rotate it, we want these to be our axes. So this is the X, this is the Y. So now when we have this converted, we should have, let's make this the X and this the Y. So this should be an A. Then we should have a B, then a C, and then a D. Nope, not even close. A, then we have a D here. Then we have a C is negative Y, and this is a B. Wait, what? Oh, this is really a minus 1. But that's fine. And this should be, yeah, fixed out length, that's fine. It should be plus n minus 1. Why is that? What is going on there? Oh, greater than A. It should be greater than or equal to A. Yeah, duh. So many bugs today. So many bugs. Well, but now we're getting it right. So, what if we have just this? Do we get it wrong all of a sudden? That is wacky. Okay, for x plus x, y plus y. Oh, something must be wrong with the cumulative sums or something. Let's double check these. xy is x minus 1y, xy minus 1, minus this, plus this fixed thing. If it's equal to C, add a 1, otherwise add a 0. I think that's fine. x2, y2 plus 1. Yeah, okay. x2 plus 1, y1, x1, y2 plus 1, xy. So let's say x equals 0, 1, 2. If x So I'm trying to print the answer for this a right here. So if that's the case, then why so many times? Oh, okay, I see. Zero is an oddball. That is very odd. How would it be 0? Answer is 0. Oh, should this be -2 as well? Maybe we should just look at -2 and -2. Yeah, let's just do that. Make things consistent. Kind of a garbage case here, but that's fine. This is, I guess, maybe the one interesting one. We do get 31. All right, I see. So now the real question is runtime, and then the real question is when we inevitably TLE, do we try and come up with silly optimizations, or do we instead, do we instead just convert to C++ right away? Well, let's try submitting. Now I'm gonna go to the bathroom. Wait, does our answer need to be a long? It is a long. That should be fine. Okay. Yeah, I'm gonna go to the bathroom. Be right back. I'll leave the mic on so you can hear what the answer is.
Problem D. Time limit exceeded. Test 7, sir.
All right, moment of truth. What is it? TLE pretest 7. Who saw that one coming? All right. Well, I never actually made that decision. What am I gonna do? Yeah. Well. We could compress this a bit. How about we just generate max case? Okay, we don't even need to store this. So a character of a plus r dot next int 26. And then this out. So let's try a 4x4, make sure it works. That's why we test. That's why we test. Good. Now let's try a 2000 by 2000. Okay. Try problem D. We need to make a new fast scanner. File reader, I think, or file input file reader. Can I have the error, please? Or do I just... Do you just not want the file, just the file name? Come on. Just give me this error. Thank you. Okay. Now, fast scanner for d.in. How long is this going to take? Oh man. Oh no. So slow. Darn. That was bad. It's not even close. Why so bad? Well, let's get the time at least. So I don't think C++ alone would be enough. We could pre-comp all these multiplies though. Yeah. That might be the play. Because multiplies are a bit slow. We also have an if statement here. Yeah, okay. So that can be in the while loop. Yeah, okay. So let's optimize this out a bit. So currently we're at 7 seconds. So we can do quite a bit. We can do if x and 1 is not equal to y and 1, then continue. So that brings us from 7.7 That was a big improvement. Okay. Divided by 2. Uh-oh. Yikes. That's a left shift 1. That's a big problem. Maybe not as big as I thought. You can make these 1 bigger and then avoid these if statements, but the if statements are super predictable. So maybe that's not necessary. These times are possibly a problem though. Oh, in here, yep. Okay, left shift 1. What's our time limit? 1 second? So insanely tight, man. Okay, let's pre-comp the values. So smaller will be I times I over 2. And then expected for, oh wait, did I just break it? I just broke it, darn it. What was I doing? Alright, let's undo this change. Is it this part that's breaking it? If x and 1 is not equal to y and 1, continue. X plus y and x minus y need to be the same parity. Oh, wait. Yeah, okay. Because we had this. So we need to make sure n is even. Or n is odd. If n mod 2 is equal to 0, then n plus plus. So now n is odd, so now this should be fine. Okay. Alright, so this is and 1, or left shift 1. This is left shift 1. What else? Okay, so this is, we need our pre-comp. Int small equals I over 2, big equals small plus 1, expected I is small times small plus big times big. Alright. Yeah, okay, so now we can get rid of a bunch of this stuff. Expected at I, that size. That didn't help as much as I'd like. Do they bound the character types? They don't. Okay, so fine. Or, oh, this might be a speed up. There you go. Or fixed at x, y is not equal to c. That might save quite a bit, actually. Not that much. Alright, so let's make our own max method. Static int max, int a, int b. Return a is greater than b, a, b. Same thing with min. 3.5 seconds. Man. Alright. Well, I'm almost at the convert to C++ part of my life here. This is all fine. Let me make sure I'm not being stupid. No important divisions. Are there any mods that are important? No. Okay, so we're just too slow. Maybe they didn't want 26 unsquared to pass. But I think we're kind of too deep to go back at this point. Come up with an entirely new solution idea. This isn't being called anywhere, right? I am using a file at least, or maybe I'm not. Okay, so what could we optimize? We could get rid of this method call. So while ants plus int bigger equals math dot or equals the max of x and y. So while bigger plus ants plus 2 is less than cs dot length are less than or equal to n, and we can make this entire condition one thing. So this is x2. This is really just x plus ants. This is just y plus ants. This is again x plus ants. This is just y. It's just x, y plus ants. X and y. Well, this equals expected at ants plus 2. Does this go any faster? Man, that's just even slower. We can remove all of these plus 2s now. Interesting. So do we try it in C++ maybe? How much time? 14 minutes. Yeah, I guess because this isn't even used anymore, right? Wait a minute, what? Why am I getting it wrong? so this should be something ending in 9, right? Not 39? So that's still fine. So now we can get rid of this. Should still end in a 9. Okay. Let's change this. Oh, it should be plus answer rather. I don't enjoy all of these optimizations. This isn't a fun way to spend my contest. What's wrong here? Oh, well, this is equal to expected at ans plus 2. Now, why would that be? Oh, these should be ans plus 2. Should be ans plus 2. Okay. Now in this case, we can make the answer this minus 2. Okay, there we go. That was the problem from before. So this is just ans left shift 1. Now we can remove all of these plus 2s. And then remove these minus 2s as well. Started at 1. We should be fine. Okay, so now we just need to convert this to C++, and hopefully that's fast enough. Yikes, we'll see. How much time? 9 minutes. Alright, go Power Rangers. Can I? Ooh, well, I can try this. Yeah, this doesn't actually change the font size, so sorry about that. I'll just make problem. What problem is this? Problem D. Ah! space sync with stdio false, cn.tie false, co.tie false. All right, so what do I need to do to convert? We need this expected int expected 3000 int board, or int or this will be some 2D array. That's a char array rather. Fic char array board would be 2000 by 2000. And char array expected will be 399 by 399. Okay. Now I think we just copy all of this. Alright, so this is fine. I think that should be good. This needs to be changed into HW, CN, H, and then W. We already have our board. String line, CN line. Okay, we already have fixed. Yeah, okay, so now N will be, this needs to get changed. This is 3999, just always, it's fine. So we go from this to this. Oh, we should probably make this CS array too. Oh, we need to fill these things with zeros. Man, that's obnoxious. Okay. Well, probably just fill fixed with zeros. What is it? It's a final? Or it's a constant, right? Constant xn equals 399. We're gonna have system.out bugs still, I think. Oh, this is filled. Or fixed. I is less than 3000. Fixed. What else would it be? What was the error message? Reference to fixed is ambiguous. What else could fixed possibly be? It's not ambiguous at all. We also need to fill CS with zeros. just make this max n as well. Oh, this is an issue. Yeah, so n equals n plus n minus 1. We can just do that. You're still telling me fix is ambiguous, huh? Why would that be? How is it ambiguous? Fix, it's just this. Max n by max n. Can you not do 2D character arrays? Can I just make an int? You found that? Fix is ambiguous. No, it's not ambiguous. It means this global array. There's no other fixed. Now, what does this error even mean? Why is this ambiguous? I guess I don't know C++. Yeah, alright, so no idea. Maybe I just submit this instead, right? Hail Mary. But it's definitely in a TLE. Okay. Well, that's too bad. Count is over. Didn't even get submitted. What do you mean it's not over? Oh, fine. It wasn't right anyway. Well, that's kind of silly. Did anyone get that problem in Java? Whole bunch of people got it. 800 people got it. Lots of people got it. I don't know. There must just be a better way. Well, I'm in the same boat as Monogon, it feels like, so at least that's some consolation. Yeah, rough contest for me. I did very poorly. Very, very poorly. But, yeah, I guess you lose some. Can't have them all. 800 solves. Well, I'm clearly missing something, because the solution I was trying was not something 800 people would usually solve. I don't know. Okay, well, that's too bad. So, solving solutions today might be pretty uninteresting, but we'll try them anyway. Because, I say uninteresting because we're solving Div2 A, B, and C, which on a normal day would be not even worth covering, to be honest. But, yeah, I guess that's all I really know how to do. I guess maybe I'll talk about D, the general idea. Let me just check something real quick. Okay. Yeah, that's fine. All right, cool. Well, very good. Let's make sure, yeah, OBS is still running, so we can do solutions now. All right, so problem A. So yeah, okay, here's the idea for problem A. Let's bring up a whiteboard. So you've got some chessboard. You want to checkerboard it, and you can color like square. So initially you've got like just a border filled in. Like this. So you've got like a 3x3 space in the middle. And then on a given turn, you can like fill in one square that touches the border. So you can fill in all of the outside border squares like this of a certain chess color. Then on the next turn, you fill in these inner squares that you can fill in anything that touches something you filled in last turn. And then the turn after that, you can fill in all of the things on the inside of that. So that's one way of doing it, but this is obviously the suboptimal way of doing it. You'd want to place blue first, because if you place blue on the first turn, then you can place all the red ones on the second turn. So that would be the better way of doing it. Here's the general way of looking at how to solve it. So if you just do it on paper enough, you can figure out that it's like 1, then 2, 2, then 3, 3, then 4, 4. And there's just a pattern here. Once you see this pattern, you just put up a pattern and submit. But in order to actually show that this pattern works, here's like the general idea. So if you've got some board, then you can delete like the outside ring here. So you delete half of the outside ring. And then on the next turn, you can delete this outside ring, like you finish the outside ring. And then you delete half of this next ring. So basically, what we've just simplified this down to is the same problem, except in this ring here, whatever the first move we would make is, we don't actually have to make that move. So in other words, if like f is the number of steps it takes on a board that's size n by n, then f of n will be equal to the 2 moves here, plus f of n minus 1, this thing, but we take 1 fewer move for that. So this is like the formal formula, and then you can see the minus 1 cancels, so now f of n is equal to 1 plus f of n minus 1, which means it just counts up by, oh, that's not true. This is n minus 2. This should be n minus 2, because you subtract 1 from both sides. So it's n minus 2, it's n minus 2 as well. So 1 plus f of n minus 2, which means you add 1 every time you increase by 2. Then you need your 2 base cases, which are what if it's size 1, what if it's size 2. If it's size 1, then that takes 1 move. If it's size 2, that takes 2 moves. So there's your proof. All right, cool. Now I guess maybe let's move on from that. Let's look at problem B. So, yeah, okay. So I solved this using a Fenwick tree. The idea is you want to see, you've got a bunch of different planks. You want to see, can you make one type of plank that's a square and then one type that's some rectangle, or possibly a square, whatever you'd like. Basically, you need 4 x's here. You also need 2 y's and then 2 z's. And then any combination of these can be equal. It's just all the x's have to be equal, the y's have to be equal, and the z's have to be equal as well. There are a couple ways of doing this. If you have 8 things that are the same type, then you can use all 8 of them. If you have 6 that are the same type and then 2 that are of some other type, that also works. In other words, x and y can be the same, z can be different, or x and z could be the same and y can be different. And then the only other way of doing it, well, I guess there are 2 other ways. You could have 4 of one type and 4 of another, or you could have 4 of one type and 2 of another. So what you can just store is you want to store how many numbers have a frequency that's 8 or more, how many numbers have a frequency that's 6 or more, how many numbers have a frequency that's 2 or more, and how many have a frequency that's 4 or more. With all of those numbers, you can figure out, can you make each of these patterns? So if you have a Fenwick tree coded up already, it does that for you. You just have to maintain what is the count of each frequency. So how many frequencies do I have of each type? And then, yeah, so the Fenwick tree is basically like it's a frequency array of the frequency array. So in the frequency array, how many things have this frequency, basically. Yeah, that's the idea. And then if any of these things are solvable, then if you have any of these combinations, then you're set. Otherwise, yeah, otherwise you can't do anything. Can't make it. When I say 4 and 2, I mean something that's bigger than or equal to 4 and something that's bigger than or equal to 2 that aren't the same thing. So yeah, that's how you solve problem B. If you use a Fenwick tree, it solves that, it maintains it for you. So that's why it's helpful. Okay, the last problem that I solved was problem C, which was really, again, not hard. But that's fine. So let's talk about it. So you have a bunch of different patty cakes, and you want to eat the same ones as close together as possible. Or as far away from each other as possible, sorry. So in this example, you have, like in this first example, you have 2 1s, you have 2 4s, you have 2 6s, and a 7. You want to eat 2 things that are the same as far away from each other as possible. So the optimal solution in this case would be 1 4 6, then a 7, then 1 4 6. And now these 2 things, they're 5 apart, but like 1, 2, or they're 4 apart, but they want you to print 1 less than that. So you print just 3 instead. That's fine. The 3s are like this. Each pair of 3 is like 1 apart from the closest 3. So you print, the answer is 1, but then they have you print 1 minus 1. So you print 0. Okay, so sure. How do we do this? So the first observation is we can binary search the answer. If we can maintain a spacing of at least 3, then we can also maintain a spacing of at least 2. Which means it'll be possible for some prefix, and then after a certain point, it'll be impossible. So we can binary search where this is. We check a given position. If it's possible, then we keep looking to the right to find the split point. If it's impossible, we keep looking to the left to find it. So now we just have to check, is it possible to do it with a spacing of this much? And we can do that in a pretty simple way as well. The observation here is that the one that you want to take at each step will be the one that you have the most left of, which means that's the thing that's like the most constraining, because you don't want to leave those all together to be at the end. So you take whichever thing you have the most of. You can do that with the priority queue. And if you know the next time you can take it will be at this step, you just say, okay, well, when I get to this step, add this, whatever, this group, add this to my queue later on. As an example, initially you have 2 1s, 2 6s, I think, 2 4s, and 1 7. So you have all of these in a priority queue, sorted by how many you have. Initially, you take one of the things with 2s, because it's something that ties for the most. So let's say we take the 2 1s. So we place a 1 here. And now we say we want to try later on whatever our binary search value is. Let's say we're saying this is the next time we can place it. We would have more spaces here, right? We'd have 7 spaces. Let's say this is the next time we can place it. We say when we get here, we should add 1 1 to our priority queue. And then we move on. So now we just have, well, we have no 1s in our priority queue at the moment because we can't place them until we get to this space. So then we'll keep sweeping through. Here, we'll see, okay, let's say we place a 6. So that means when we get here, we want to add 1 6 to our priority queue. Now we don't have 6s in our priority queue anymore. Now we place a 4 here. So now we have 1 4. We should add when we get here, etc. So now in our priority queue, we have a 7 and we have this 1. So let's add the 1 to our priority queue. So now we have 1 1. We can take whichever one of these we want, doesn't matter, and then we put that here. So it doesn't actually matter what this final array is. You could extract it pretty easily if you needed to, but that's one way of doing it. All right, so yeah, that's problems A, B, and C. I can talk about my idea to problem D, although it seems pretty clear that my idea is not intended, because it is very tricky to get to pass. And also other people who, I don't know, I would imagine are not usually super good at optimizing, got it to pass. So yeah, I'm not sure. My idea is that if you have like if you've got a 2D grid like this and you want to turn this Manhattan distance like a diamond, if you want to turn this into a rectangle, which is usually easier to work with, instead you can make your axes, you can make this your x-axis and this your y-axis. In other words, the x-coordinate of something will be its x plus its y, and the y-coordinate will be x minus y. And now we have like a new version of each point. So we can transform each point in this old coordinate plane to this new coordinate plane. Some things now, they might have a negative x coordinate, so you have to remember to shift everything, or a negative y coordinate, so you have to remember to add a constant to the y coordinate. You want to add n minus 1, because that's the smallest negative its y coordinate can be. And now after that, you have a shifted version of this grid, and you want to see when does it look like something else. So yeah, that's the idea. Now, basically, on top of that, now we just have a grid of 1s and 0s, and we just want to see what's the largest subsegment of 1s here. And you can do that pretty quickly with, oh, maybe you can do it better even. Yeah, you could do better. You could do better than what I'm doing. If you just start at the top right, then when you start at the top right, you want to say the answer for this position here. It's either, like, assuming we're only looking at things that are the same character. If the thing above you is different, or the thing to your left is different, then the answer is going to be 0. Or the thing like right next to you is different. But otherwise, like, now we're looking for a grid that looks like this, basically, right? It's like kind of checkerboard patterned, because the only spaces that correspond to real squares here are spaces in which x plus y has the same parity as x minus y. In other words, if you add two even numbers, they're going to be even. If you subtract two even numbers, they're also going to be even. And if you add two odd numbers, they're going to be even. If you subtract two odd numbers, they're also going to be even. So basically, both of these have to be not the same parity. They have to be, I guess, x and y. Yeah, these have to be the same parity. Also, both even. Well, no, whatever. Same parity. Okay. So, yeah. I won't spend too much time on that, but if you like draw out a case by hand, and then you convert everything using x plus y, x minus y, you'll see why that's true. So now for a given space, the amount this square works will be equal to the amount the square above it works, and the amount the square to its right work. And then it also has to make sure that amount works as well, like in the top corner. So those are two constraints. And if both of those work, you have your minimum value, and then you can keep adding on from that as well. So let's draw a bigger example that's maybe more clear. So if you have, let's say you're considering this spot here, and you know this square works. Those square is entirely filled with 1s. There are no 0s in this square. You also know this square here is entirely filled with 1s. But for some reason, like, if we extend this by 1, then it doesn't work, which means there's a 0 somewhere here. There's also a 0 somewhere here, maybe. So the biggest the square that we're trying to figure out could possibly be would be this size. That's the biggest it could possibly be. And on top of that, we can check if this works just by checking the single point here. So we can check this position in order 1. I kind of did it going backwards, but I'm pretty sure it's the same runtime. I just had lots of TLE issues. I think the trick to make it run fast enough is you don't have to do this for every character. for this position, you only have to check the character that's on this position in the board. So if you do it like that, then your final runtime is n squared, rather than n times the number of letters. I was trying some n squared times 26, and that TLEs. All right, hopefully my my webcam wasn't blocking too much of that. That explanation made sense. All right, yeah. I didn't spend any contest time at all thinking about problem E, so I would just be more or less guessing on that. It did get solved only by 3 LGMs and this guy. Oh, and this guy. So 5 people solved set. I think that means your Div2 set's too hard, to be honest. That should be like a Div1 level set. 5 people are solving set, then that's like a good difficulty. But you had Div1s competing, right? This guy used to be an LGM. He's an ex-LGM. And this guy here, he was an international grandmaster. Now he's, I guess, just a grandmaster. Still though, that was way too hard for a Div2, in my opinion. Like, problems should have been easier. Maybe if you left it at just E1, maybe that would have been fine. If you didn't have E2. How did anyone for whom it was even rated for solve? Yeah, if we don't show unofficial, what do the standings look like? Yeah, so it would have been almost perfect difficulty if they didn't include E2. Yeah, I guess difficulty curve isn't bad. Maybe D should have been a bit harder, actually. Yeah, if D were a bit harder and they just didn't include E2 at all, that would have been fine. Although I didn't even solve D, so yeah, just not a great day for me. Well, anyway, that's enough about this round. Yeah, I hope you enjoyed, and happy upsolving. Have fun doing that. I will be for sure as well. And that's all. Thank you for watching. Goodbye.